So this is the Leetcode algorithm portion of this challenge. Today is day 25. Let's go ahead and find ourselves an easy Leetcode algorithm question to solve. Pick one. Alright, let's look at the problem list. This one is an easy one right here. Let's see. Count hill and valley in each array. What is a hill and a valley? Let's look at example. Num 241165 and 241165. Alright. So let's see. Output 3. There's 3 hill here. So boop, up and down, boop, up and down. Unless you're counting valley, boop, 1 valley, 2 valley, and 3 valley. Counts hill and valley. At index 0, there is non-equal neighbor 2 to the left, so the index 0 is neither a hill nor a value. At index 1, the closest non-equal neighbor of 4 are 2 and 1. So since 4 is more than 2 and 4 is more than 1, index 4 is a hill. At index 2, the closest non-equal neighbor 1, 4, and 6. Since 1 is less than 4 and 1 is less than 6, index 2 is a valley. Wait, what? Index is 0.2. Where is going on? It's a valley. At index 3, the closest non-equal neighbor 1 of 1 are 4 and 6. Since 1 and 4, 1 and 6, index at 3 is a valley. What? X3 is since index at 3 are 1 and 1, 4, and 6, index 3 is a valley, but note that it is part of the same valley as index 2, okay? At index 3, at index 4, the closest non-equal neighbor of 6 are 1 and 5, and it's a hill. Index 5 is a non-equal neighbor of index of 5 on the right. So index 5 is neither a hill or valley. Okay, so we're only going to check these value. Is this value the highest value or lowest value of the two? Oh, it's the highest value. So that's the hill. This one, is it the highest value or the lowest value? The nearest hill is 4 and 6. So that's gonna be a valley. Index 3 is a valley, but note that it is part of the same valley as index 2. The closest non-equal neighbor of 6 and 1 are 5. Okay, so that's pretty easy. Well, there's some trick to it. Well, let's look at this one right here. So this number, is this a hill or valley? Well, this number is higher than 5, so that's a hill. No? Wait, hang on a minute. There is no equal number to this left, so the index 0 is neither a hill or valley. Index 0, no non-equal neighbor to the left, so the index 1 is neither a hill or valley. At index 2, the closest non-equal neighbor of 5 are 6 and 4. 5 are 6 and 4 and 4 and 6 and 4. 6 and 4. At index 3, the closest non-equal number is 6 and 4. So 5 is neither a hill or value. Next 4, the non-equal neighbor to the 4 are 5 and 1. Since 5, okay. Yeah, I kind of get it. So we're looking for all the middle number being the highest or the middle number being the lowest of whatever the next adjacent number is. So how do I want to solve this? If I take this array and I subtract it by itself, by the front of number, so if I equalize it all out, can I sort this? No, I can't sort it. So pick up a 2. Are we going to use 3-pointer here? I got a feeling we're going to use 3-pointer here. So the first pointer is going to be left, center, and right. And the first pointer is going to be left, center, and right, right? And center is going to be right here. So this one, in this case, 4 is higher, so we're going to increment left, and if that's the case, we're going to increment left, center, and right. But left, center, and right. All right, let's say this number. Well, this number is still the lowest value. What if we just increment right until we find if we increment right, well, this one, 4 and 1, 1, let's see. 4, 1, 1. Where is that at? 4, 2, 1. 4, 2. The neighbor of 4 are 4 or 2 and 1. 4 are 2 and 1. And since 4 is bigger than both, so if the center number is bigger than both the left number and the right number, that's a hill. Index 1 is a hill. Index 1 is a hill. Cool. What about the next one? 1 is less than 4 and 6. So index 2 is a valley. Index 2 is a valley. Cool. The closest non-equal neighbor of index 1 are 4 and 6. Again. So do we increment the right pointer until we find the number that is not equal to the current number? Alright, so we iterate through the loop. Look at this number the first time. Oh, that's a hill. Cool. If we find the hill, increment the right pointer until we don't get the number that we got it for. On the next iteration, increment the center. Increment the center. Increment both center and left. Okay. Right pointer we got to here, right? The center. Now we're here. We only want to update. Okay, so this is +1 again. Cool. Well, we're not going to move the center. Center is not equal to R yet, so we're not going to update L. If center is equal to R, then update L. Okay, cool. Now center, so center is here. We're going to increment center again, but R is still in the same place. So that's a valley. Cool. Now we're going to increment. Now R is set to the same as center. But that's just overcomplicating the logic. While in the while loop, I can just increment the counter because we know that the number is the same. But what if it's a decreasing sequence? Well, if it's a decreasing number, what if instead of this number, it's being a 6, it's a 0? So 4, 1, 1. So this is a hill, right? But it's a plateau. It's going down. Right is now equal to 0. Is that a hill? No, it's not. Well, yeah, if it's a hill, if it's a valley, then we check the key to see if the condition is true or not. If it's a valley, then we know that it's okay, this number is still not true. We increment the right pointer until we get to a different number. If it's a valley, then increment the pointer to the next one until we get to the valley. Check to see the condition is not true, then increment the valley. And we got to 5. That's a hill. That is a hill, so we increment the center point one more time until it's R equal to C. Okay, so I think I got it. Left, L equal to 0, R equal to 1, C is equal to 1, and R is equal to 2. So for I in range of C of length of nums, we're going to get to the first one and then length minus 1 minus 2. So what that's going to do is that, and this is going to be our center column right here. Length is equal to length of num. Okay, let's print out C real quick. C 1, 2, and 3. 1, 2, and 3. 1, 2, 3. Length minus 1. It should be 4. 1, 2, 3, 4. 0, 1, 2, 3, 4. Cool. So now we can do there's probably a much easier way of doing this. I'm using 3-pointer. There's probably a much easier way of doing this. So C is going to be in the middle for sure. The first time we check to see if left L, if C is more than L and C is more than R, how about we do left equal to nums at L, C, center, and this is right. If center is more than L and center is more than right, left, and print hill. Res equal to 0. Res plus equal to hill plus equal to 1, else else if center is less than left and center is less than right, res plus equal to 1, 2, else if it's not neither of those, then we want to increment the counter until, well, let's say R is right here, right? Let's say L, C, and R. So we want to increment the counter until R is a number that is not the same as the previous number, while R or center is equal to nums at R, nums R plus equal to 1. Or we get to the very end of the array, or R is less than, and R is less than length, which is the last one. Length minus 1. R plus equal to 1. So that's going to increment the counter until we get to this point right here. And that figure 1, else if, else 1. But when do we increment L? And we want to increment L when we find this array. When we find a hill, increment L, L plus 1. L plus 1, now L and R's, and L plus equal to 1, L plus equal to 1. Cool. L plus equal to 1, and then C is going to auto increment on the next iteration. And when we get to here, when none of this condition is met, well actually, well in this case, one of the conditionals are already met. In this case, we don't want to increment L because we find a value here, but R is way over here. When C is equal to R, that means C have caught up to R, then increment L. Whew. When C, okay, now that we got to here, right? We don't want to increment L here. If, oh shit. If C equal to R, L plus equal to 1. That means we caught up to it. But right now, the first time we went through, C is not equal to R. But now that we are caught up, so C and R are at the same place. C and R is in the same place. We want to increment L one more block. And now we're going to go back to C and R here. C and R. No. Yeah, let's look at the loop solution. I don't think I'm doing it right. Python 3. Is it that simple? Is it that simple? If num at I is equal to num at I plus 1, num at I is equal to num at I minus 1, num at I minus 1. Oh, we carry the number over. Holy shit, that's pretty genius. Okay. Okay, so we can do, instead of doing a 2-pointer, we just carry the number over. That's pretty genius. So if nums at I is equal to num, if the next number is equal to the previous number, I plus 1, then we carry the number over. Num at I is equal to num at I minus 1. Okay? Else, and if, now this is the condition check to see if the num at I is more than num at I minus 1 and num at I is more than num at I plus 1, then res plus equal to 1. Okay, now we just swap this case right here, and in the end we're just going to return res. That's genius. For I, nums at I, line 8. That's genius. Okay. Yeah, I feel like my maximum brain capacity is like less than 1 hour for these kind of problem. Maybe I can stick to the easy SQL problem next time and then focus my energy on these